Greetings and welcome, friends. Mr. Waddy and my fellow geometricians. We're talking about like perimeter, which is the distance around stuff, and area, which is like the two-dimensional space that it fills. In the coordinate plane, which is like the location of things mathematically represented on a number line. But then what if there were two number lines and they represented like all of these possible locations of things on them on a planal surface? Not unlike battleships. So here we go. Polygons. In geometry, a figure that lies in a plane is called a plane figure. Recall that a polygon is a closed plane figure, so it connects to itself. There's an interior and an exterior, okay? Formed by three or more line segments. All right, so these are linear segments. They can't have like a like curviness to them, called sides. Notice it says three or more because can I draw two line segments that connect? That I can't I can't get this one to wrap over. No, so it's got to be three or more. So like triangles or more sides than that. Each side intersects exactly two sides, one at each vertex. So the vertices you can see are labeled with the A's, the B's, the E's, etc. So that no two sides with a common vertex are collinear, right? So like if there was like a point F here, that's not those aren't like two separate sides. That's just one side. Come on, like that doesn't count. That doesn't count. And you can name a polygon by listing the vertices in consecutive order. So this is Polygon Abacadae, but you also could have started at the E and called it Eabacad, right? Or you could have gone this way, Edkaba, right? Like you can really just any consecutive sequence of those letters will be a polygon's name. And we will end up talking about all sorts of cool polygons later on in this course, but today we're talking about area and perimeter. But there are some polygons that we should know by name. You can classify polygons by the number of sides. That's one of the ways you can do things. Shown in the table, which you'll see in a moment. Ooh, here we go. Right, Ryan is pumped. Here he goes, paying attention. You can also name a polygon using the term n-gon, all right? Where n is the number of sides. For instance, a 14-gon is a polygon with 14 sides. So in terms of this table, you guys know most of these by name. Actually, I've even been training my my 5-year-old Everett. He knows some of these by name. Ones you probably don't know. Heptagon, you probably don't know. Nonagon, I think, is pretty great, right, for 9. Decagon, dodecagon, and then what's up? What's your thoughts? I would guess 11gon, or an oncegon if you're a little bit Spanish in your pronunciations of polygonal names. I don't know. I can't think of that. And like a dodecahedron will be a 12-sided 3-dimensional solid, but that's really jumping the gun. What's a 20-sided? My icosahedron is, so icosagon might be a 20-sided polygon. Yeah, I don't know. Then there's also this concept of another type of classification of polygons, describing whether or not they are indented or not. Like if you're getting like a dented can discount at your grocery store. Convex polygon is undented, whereas a concave polygon, it kind of like caved in right here. You can see, ouch, right? Someone dented that. If you were to connect the vertices, you'd notice like, hey, there's this missing piece that's dented in. So concave, it's caved in. Another way I like to think about concave, let's see, can I get a good rubber band color? I think this is a good rubber band color. Imagine if I took a rubber band and wrapped it around the, that was so sad. It was like going to be amazing, and then it wasn't. And wrapped it around the exterior of this polygon. When it became taut, the edges for most of it would be right up against the edges, right? Except for right here. It would go from this vertex to this vertex. It would not be touching those edges. And so the rubber band test is what I call that one. If you want to think about it like that. I think that's a pretty good rubber band color. Maybe not. I don't know. I'm not sure. Well, anyways, yeah, let's look at example. Oh no, I zoomed out. I got the zoomies, which is actually what we would say about our dog when it would get all hyper and running around in a field. Stormy's got the zoomies. Not that she knew how to mouse scroll, wheel scroll, or anything like that. I've never seen her do that before. Classify each polygon by the number of sides. 1, 2, 3, 4. So this is like a fouragon? No, it's a quadrilateral. Also, notice I tick marked this. Oh, there we go. With 4 different dimensions. I don't know. It looks kind of like these two are congruent to each other and like these two could be. But unless the geometry tells us, I cannot make such assumptions. Did you have a question, Emmett? I want you to get kind of familiar with these names over time, but quad is like 4, so yeah. Quarter is like 4 coins that make $1 is a quarter. No, I'm pretty sure it's pronounced quarter, which is also the means through which you can commandeer a shopping cart at Aldi's. Is a quarter. You rent them. And then you get your quarter back, yes. I was so confused the first time I went there, I actually used my car keys to hijack it. I still returned it back to its appropriate corral. I put my car keys in there. I didn't know what I was supposed to do, and I didn't have a quarter. But anyways, this is a quadrilateral question. Is it convex or concave? Concave. Yeah, because it's definitely like dented right there, right? You could theoretically imagine a polygon that's multiply concave as well. Like it could have more than one dent. Looks like this has 6 sides, so this is a hexagon. And convex agon, more like it. No, not real. No. All right, finding perimeter and area in the coordinate plane. So it is also possible to imagine these figures placed upon a grid with axes and numerical dimensions so as to describe the location of said vertices. But before we can do perimeter and area in the coordinate plane, using distance formula, for instance, we would need to make sure we know these area formulas. We talked about some of these just before this lesson. So this is half the base times the height would be the area of a triangle. Perimeter, you just add up all those sides. Area of a square, you just take the side length and square it. Area of a rectangle, multiply the length and the width. The width. All right, man, that was the grossest. And then we also talked about Trapezar, the awesome fire type Polygon, who's a 4-sided, not rectangle or parallelogram, but with 2 sides that are parallel to each other. And the area of a trapezoid is going to be half the height times the sum of the bases, b1 plus b2. All right, so I'll just throw that there because Sus Libro did not include it. Bam, something like that. Just add them all up, whatever. Yeah, you'd have to find it. Although the little sides of the trapezoid are going to be forming little right triangles, so you could see the use of Pythagorean theorem to find like a C1 and C2 sort of situation for the hypotenuses, the hypotenusae of those little triangles there. Let's see. Oh, I so hope I gave myself a grid for this next problem. Do I need a grid? I don't know. Oh, nah, not really. Not really. This just asked for the perimeter of triangle abac. Let's see how well I learned my lesson about distance formula. So it's the x2 minus x1, I'll call it, squared plus the y2 minus y1, all squared. And so to find the perimeter, I'm going to need to find, all right, here we go. Let's find AB. Let's find AC. And we'd also need to find, I don't know, probably BC or CB. Yeah. Yeah. I think so. So, although, ooh, guys, check this out. Let's imagine I graphed this for you. Did I give you a graph? I don't know if I did. Did I? I'm super friendly. Good job, Mr. Waddy. So imagine I plotted those points on a coordinate plane. Remember to plot a point. -2, 3 means you start at the origin, go left 2, up 3, plot a point. So I actually only need this version of the distance formula for A to B. So I'll do that one for starters. So that's the square root of A to B. So that's going to be 3 minus a -2 squared plus a -3 minus a 3 all squared is equal to 3 minus a -2, 3 plus 2 is 5. And -3 minus 3 is more negative, it's -6. And I square those fellas, and I'm going to get 25 plus 36. And I'm going to get 61. Square root of 61, by the looks of things, is the distance here exactly, which is approximately, let's see, actually I could just cheat, 7.81 according to your book. Now I don't know what these units are, but this would be measured in units for sure. Now as far as these distances, I don't have to use this distance formula, but I can. But do you guys know another way I could find AC? Yeah, the absolute value of the difference of their coordinates, depending on, these are vertically aligned, so I chose the vertical coordinates, the y's. So I'm going to subtract them and take their absolute value, because distance is positive. 3 minus a -3 is positive 6, and ab 6 is 6. So so there we go, we get 6 there. And then over here, I'll do the similar thing for the base A. Is going to be -2 minus 3. I'll do it the negative way just so we can see. So that's equal to abs -5, which is equal to 5. Also, I want to point out, if I knew the 5 and the 6 first, that I could then have used Pythagorean theorem to find this, and it would have given me the same result. So the perimeter is going to be 5 plus 6 plus 7.81. Well, ish. That would be an approximation there if I add them all up. So the perimeter is approximately 11 plus 7, 18.81 units. I'll throw a little U there just for you guys. Also, because this is a right triangle, I could also have found the area, but I won't do that right now. But this would have been the height, this would have been the base. Yeah, it'd be a little trickier if it was non-right. Oh, all right. So perimeter, if it's got 4 sides, what do you think you would do for perimeter? Yeah, you just like use the distance formula, find 4 sides, and then add them up. Add them up. Yeah. Let's take a look at example 3 here, so you guys can flip a few pages there almost, I imagine. Example 3, finding the area in the coordinate plane. And the area formula I use is going to depend on the shape of the figure I have. All right, let's see what I can do here. Man, I love these pre-made grids. Thanks, Past Waddy. So let's see, let's plot these points. D is at 1, 3, so over 1, up 3. And 4, -3, over 4, down 3. There's an E. And F is at -4, -3. So there's an F. Let's see. Let's use my line tool just so I can be awesome and pretend I'm great. Something satisfactory about. Oh, look at that. Would you look at it though? Would you look at it? And then look, I'll just swing this over there. Oh yeah, that's a triangle, friends. Got 3 sides. That's a polygon. Is it possible to have a concave triangle? Yeah, I can't dent a triangle, friends. You just can't do it. So let's see. If I want to find the area, what do you think I should call my base? I think EF would be the easiest to be my base. Although technically any of the sides can be bases, but whichever base I pick, I then need to have a height that is perpendicular to that. But because E and F are horizontally aligned, I'm going to call that the base, and the height is going to be this from D to the side, FE, and a right measurement to it. So let's find EF. Now, in terms of distance formula, I can just do the absolute value of the difference of EF's x coordinates, right? That's not there. There we go. So 4 minus a negative 4. Oh, this is going to have a distance of 0? No, I don't think so, Ryan. What are you playing? Clash of Clans over there? No? No? Oh, definitely not? Is that Ryan's official game review of Clash of Clans, a game made by Finnish people? What? Yeah, you're right. I know what I'm talking about. Clash Royale, also same company? Supercell, good for them. They also did what, Battle Beach or something? Too bad for them. Boom, or sure, whatever. Okay, but yeah, you can put away your Clash Royale, or we will royally clash. How about they? Yeah. So, anyways, so here to find the height, I want to point out the height. So here's point D is 1, 3, not negative 3, and E and F had the same y coordinate, right? Something comma negative 3, something comma negative 3, right? And all of these points will have negative 3 as their y coordinate, right? Actually, what do you think the x coordinate would be here? Yeah, it's got to match that one. I didn't even need it, but I can find it. It happens to line up so nicely there. And so I'm going to find the distance between a 3 and a negative 3, and that should be my height. So I'm going to say h is equal to the abs val of 3 minus a negative 3. There we did it. All right, so h equals 6. So the area formula of a triangle is half the base times the height. So I'll plug in what I know and solve for what I don't. So half the base times the height. Half of 8 is 4. 4 times 6 is 24. So 24 units squared, like so. Bam. Lovely, lovely. Good job, friends. Look at those straight lines on that triangle. I didn't do the straight line on the height. Also, sometimes I like to draw my height with a dashed line. So classy, so classy. All right, where do I need to go next? Let's see, example 4. Yeah, and then I'll just do example 4 and then we'll call it. Ooh, blueprints. Actually, if you guys ever take a drafting class, I don't even know if those exist anymore, because who draws things non-digitally anymore? But do they draft? Excellent. So here we go. If you've taken a drafting class, though, back in the day, they used to write on their blueprints all capital letters for things spelled out. Man, and it's just it's pretty classy to write in all caps. Except when you're on the internet, because then people think you're yelling at them. So be cool. Calm down, everybody. All right, thank you. All right, so no all caps for the internet. But all caps handwritten, pretty good, pretty good. You are a building, but you're not. You're building a shed in your backyard. The diagram shows 4 vertices of the shed. Each unit in the coordinate plane represents 1 foot. Find the area of the floor of the shed. Now, there is a test question, let me warn you of this, where they've got a similar setup, and then each grid unit is 2 feet, and those jerks then throw all of us off, and so beware of that, pre-warned. Yeah, look out. Make sure you're paying attention to the scale here. Also, if I was making this, I would have just said, let's just make the origin of my graph right there, and this would have been so much cooler and easier. It's too easy. Let's see, so if I need the area, let's find let's find kj, the distance. And so those are horizontally oriented to each other, so I'm just going to do abs 8 minus 2 is equal to abs 6. Whoop, that got like almost like a parenthesis for a second there. So that's 6. And then we'll find gk is abs 7 and 2. So 7 minus dose is abs 5 is 5. And there you go. 6 times 5, the area will equal 30, right? El más fácil del mundo, friends. So this is going to be in square feet. Squeet, even. In this case, you could have actually gotten away with just counting the number of squares in the picture. But don't do that on that test question, friends, because I'm telling you, those squares do not represent square feet. No. And then also don't count the squares and then try to double them because you're like, oh, 2 square feet. Oh, 2 feet by 2 feet is 2 square feet. That's not the case. If these were 2 by 2, the area would be 4 square feet. So you'd actually have to quadruplify it, which is not a math word. But thanks for watching, Internet friends. Have a great day.